To recap, in part 1 of this series, I introduced an unreleased app I was working on last year called FlipStream. It uses social media and spaced repetition principles to help memorize information through the use of flashcards. The front end is written in Apache Cordova, using HTML, CSS, and JavaScript. So, with no frameworks or libraries, how do we structure an application? The good news is that the nature of the three main browser technologies already gives us the answer. HTML provides the semantic structure that will support the app and all of its functions. By using custom elements and the Shadow DOM to build web components, we're able to build HTML that represents the structure of our application and its components very closely. CSS controls the presentation, obviously, but it also controls something less obvious, the state of our application. State and presentation are very closely bound, and by using CSS for both, we greatly simplify the last area of responsibility, the application logic. Without JavaScript, we wouldn't be able to build a very interesting application. But by dividing the responsibilities more evenly between these three areas, you'll find that you can write less code and get more functionality. Let's start by looking at the structure of our application from the top down. At the very top of our tree is the entire app itself. Within the app is the header and the footer. Everything else is the app's content. Within the content is the feed, and within the feed is a sequence of cards. So let's see how to translate that into HTML. This is the main HTML source file for the application. Notice the tags describe the semantic structure of the application we've already defined. They all have the FS prefix because custom tag names must include at least one hyphen, but otherwise they reflect their semantic purpose within the app, which leads us to the secret weapon when it comes to building dedicated JavaScript applications: web components. Web components are actually just the application of existing web standards to produce reusable HTML components. They use custom elements, i.e. tag names with a hyphen in them, the Shadow DOM, which provides a way to attach a private DOM tree to an element and hide it from the rest of the public DOM, and the HTML template element, which allows us to embed HTML on our page that isn't processed by the browser. Some advantages of web components are that they can mimic native HTML elements. They can be defined directly in HTML source code or created using document.createElement. They use HTML template tags and the Shadow DOM to include internal markup that doesn't leak into the public DOM tree. And they are fast. By eliminating the double DOM that's required by some modern frameworks like React, web components can be considerably more performant than framework components. As with every technology, there are some disadvantages too. Using the core APIs, JavaScript is used to do everything from constructing markup to manipulating CSS styles. I would really prefer to write markup as markup, CSS as CSS, and JavaScript as JavaScript. Browser support has been somewhat inconsistent, and the standards have evolved considerably over the past few years. This makes web components a questionable choice for a public website, but since we control the rendering engine, that isn't an issue for FlipStream. And because web components are really a repurposing of core web technologies, there isn't a huge market for documentation and learning tools. This creates some serious hurdles for developers who want to start building their own web components. To address the separation of concerns issue, I've developed a very lightweight framework I call plain HTML components. It's designed to make developing web components easier. The quickest way to understand how they work is to look at an example: the lowly slug. Anywhere in the app where a user's avatar is shown is rendered using an FS slug component. This component supports a single property, an email address. When the email address is set, it uses the WordPress Gravatar service to render an image for that user. Now let's look at the plain HTML template behind this component. Each component is declared in a single HTML template element. All the required styling, markup, and code for that component are included in the component template. The custom tag name is used as the template's name attribute. Inside the template, the style tag contains all the styling for the host element and Shadow DOM content. The host element is the public element, in this case an FS slug element. The script tag contains the class definition for this component. The name of the class is automatically generated based on the tag name, using title case for each hyphen-separated word. In this case, FS slug extends FS element, a common superclass for all components in the FlipStream application. The FS element class extends the plain HTML PH element class, which extends HTML element and also offers some additional functionality, like reflecting attributes to object properties. For instance, the FS slug element maps the email attribute to the email object property. That means that it is possible to initialize custom elements by providing attribute values in your HTML source code. The rest of the markup inside the template element is used to initialize new component instances. All new FSLug elements contain an image element with an ID of avatar in their shadow DOM. That ID is scoped to a specific FSLug instance and can't be accessed by the public DOM. There's also a slot element which allows users of the FSLug element to inject their own markup into the rendered component. The content inside the FSLug element will be injected into the web component in place of the slot elements in the template. The mechanics of slots, the shadow DOM, and other web component topics are beyond the scope of this overview, but for more information, start at webcomponents.org. And if you'd like to play with the plain HTML library, it's available using the MIT license on GitHub. Earlier, I mentioned that CSS is not only useful to control presentation, it's also an important way to manage application state. As an example, let's look at how the app manages the UI of a card component. This card currently has two CSS classes, CanDelete and CanEdit. These classes control the user interface by showing and hiding menu items depending on what permissions are available. Deleting the CanEdit class will immediately change the display of the menu. Putting it back displays it again. And if we click the Edit menu, the editable class is added. This completely changes the UI of the card using CSS selectors. There's no code, no DOM re-rendering, the browser handles everything for us. Using CSS to manage UI state removes an entire class of potential errors and as a side benefit makes our UI updates as fast as possible. In the next video, I'll discuss the server side of FlipStream, which uses CouchDB and a proxying app server written in Python. Thanks for watching.